Let us proceed with other serviceability requirements for the design of reinforced concrete beam, slab, and staircase. We talk about the maximum reinforcement bar areas. The maximum reinforcement bar areas is set in order to ensure that the RC member is always under reinforced. When an RC member is under reinforced, that means when it comes to the failure at the ultimate state, the tension reinforcement bar should fail first. Because of the characteristic of the steel reinforcement, after yielding, the reinforcement bar undergoes significant elongations. Such a deformations can lead to excessive cracks on the surface of the RC members. This leads to ductile failure of the members, and the crack on the members can easily be noticed as a warning sign that the members is about to fail. This behavior is very important for survival purposes. In the case of the members fails, it doesn't fail suddenly. It gives sufficient warning signs so that remedy can be taken. Therefore, it is very important to ensure the maximum reinforcement bar is not exceeded. The maximum bar areas is set as 4% of the cross-sectional area of that particular member. AC here refers to the cross-sectional area of the member, which is the multiplications between the B, the width, and H, the height of the member. If you observe the formulas in any other areas, most of the calculations, it will be on basis of the effective cross-sectional areas, such as when you calculate decay, when you calculate the VRDC, when you calculate the VRD max, when you calculate the AS min, and etc. It is only when you calculate the AS maximum, you are using the AC, which is B times H. You are talking about the gross areas of the structural element instead of the effective cross-sectional areas. Next, for you to check the maximum reinforcement areas, theoretically you will have to check for all the beams, slab, and the staircase. However, due to relatively large sectional areas of the slab and the staircase, the maximum bar areas is not likely to be exceeded. Even though you check, the chances of passing is relatively high. Therefore, the maximum bar areas, it will be more critical to the beam when the effective cross-sectional area is relatively small. Next, we talk about the minimum spacing. The minimum spacing refers to the clear spacing between reinforcement bar. The purpose here is to permit the concrete flow around the reinforcement bar during the constructions. When you need to check for the minimum spacing, you will have to check the spacing between the top reinforcement bar and also between the bottom reinforcement bar. Based on the amount of reinforcement bar calculated, you will need to propose a suitable numbers of reinforcement bar and a suitable size. And then you have to arrange the reinforcement bar in the manner that it is symmetrical at the center. This is the arrangement of a typical 2 reinforcement bar for the beam. When you have 3 reinforcement bar, it will be arranged in this manner. 4 reinforcement bar, it will be arranged in this manner. and so on and so forth. The minimum spacing is defined by three conditions here. First is the largest bar area. Let's say for this, you're providing 2 H20 and 1 H12. Then the maximum bar size, it would be defined by 20. This is what it means by the maximum bar size. Another one, it would be at least 20 mm. And also the maximum aggregate size plus 5 mm. Under normal circumstances, the maximum aggregate size is 20 mm. That will lead to you 20 mm plus 5 mm. Considering these three conditions here, the largest value, it will be the minimum bar spacing. This is expressed in the equation here. The minimum bar spacing will be checked against the actual spacing. Based on the arrangement of reinforcement bar, you estimate the minimum spacing and check against the required minimum spacing. If you see the table here, you will find the checking for the minimum spacing, it will be more relevant to the beam, but not really an issue to the slab and the staircase, due to relatively large cross-sectional area of the slab and the staircase. And normally when we arrange the reinforcement bar in the slab and the staircase, we prefer the reinforcement bar to be more widely spaced, as this can reduce the amount of the work. For the same required bar area per unit spacing, larger bar size will lead to greater spacing, as the numbers of the bar required for the same amount of the area reduces. This is going to save your times tiling the reinforcement bar during the constructions. Normally, we prefer the spacing of the reinforcement bar in the slab and the staircase within 100 mm to 300 mm. It is unless the members is heavily reinforced. The closest spacing recommended, it will be 75 mm. 75 mm is good enough for the passing of the concrete during the casting. Therefore, the minimum spacing will not be an issue for the slab and the staircase. If you provide the spacing, at least 75 mm. Next is about the curtailment. Curtailment means that at certain designated places, when it is not necessary, the amount of reinforcement bar may be reduced. And such actions of reducing the amount of reinforcement bar will have no effect to the strength and the structural integrity of that particular member. Normally we do curtailment in order to save the materials, saving costs, and also to prevent the congestions of the reinforcement, especially at the joint between different structural members. Taking this continuous beam as an example. This is the beam here, and you will have incoming beam here. This is the incoming beam. You expect there will be reinforcement for this beam. There will also be reinforcement for this incoming beam. Ultimately, the reinforcement should meet at their joints. Imagine you are providing the full amount of reinforcement bar entering the support, whereas the incoming beam also you are providing the full reinforcement bar. When they meet at the joint here, you're going to expect the joint to be highly congested. This is going to make the work very difficult, as the reinforcement when the concrete covers is made consistent, they will clash into each other, and you will need to make ways for the incoming beams reinforcement to go through it. Congested reinforcement bar may also lead to an issue with the minimum spacing that is not sufficient for concrete to freely flow through and surround the reinforcement. Now, if the work is not properly done, the joint of highly congested part, it would be the weakest link of the entire structural system. This ultimately can jeopardize the integrity of the entire structure. This is about the curtailment. Bear in mind that there are curtailment for the beam and curtailment for the slab. They may look identical, but in fact they are different. This is the curtailment for the beam, and this is the curtailment for the slab. There are rules of applications of the curtailment, both for the beams and for the slabs. And you know that this curtailment rules is not given in Eurocode 2. It is based on the previous code of practice. So when you do the curtailments, make sure you are using the right one. Even for the beam itself, the curtailment for simply supported beam and the continuous beam differs. Same goes to the slab. Simply supported, continuous, and cantilever. Bear in mind that not only you need to check the applicability of these curtailment rules, the curtailment should not supersede the serviceability requirements as listed for those that we have discussed previously, particularly the minimum bar areas. Make sure when you do the curtailments reducing the amount of reinforcement bar, the minimum bar areas must be complied. Now we have the curtailment rule for the beam and the slab. How about for the staircase? Personally, I am not aware of any curtailments for the staircase. If you encounter one, feel free to share. And what I would do when need to do the curtailment for the staircase, probably I will adopt some principles from these slabs. Now if you are not confident, might as well you don't do the curtailment for the staircase. Just that you will use slightly more materials, which may not seem to be necessary. Since you are not confident, to be safe, you don't do the curtailment. This brings to another point. Do you really need to do the curtailment? In fact, if you don't do the curtailment, it is no harm, as the reinforcement bar that needs to be curtailed is normally more than enough. If it would not lead to critical issues like the bar congestions, and you are not really concerned about the cost of the material used, even though you don't do the curtailment, the structure is still safe. These are the serviceability requirements for the beam, slab, and the staircase. Next, we talk about the anchorage length and the lap length. The anchorage length is required for the sufficient bond between the reinforcement and the concrete. For a reinforcement bar embedded in concrete, you need at least certain length so that the stress can be effectively transferred between the steel bars and the concrete. If the anchorage length is insufficient, the bond between the concrete and the steel bar is insufficient. This may lead to slippage of the reinforcement bar from interlocking with the concrete. Under such circumstances, the concrete and the steel bars are separated. When the concrete and the steel bars are separated, that means it is no longer a reinforced concrete member. Steel bar cannot be used to strengthen the concrete, and the structural element will fail. This is the equations used to calculate the bond as given in Eurocode. For more information, you may refer to the Eurocode or refer to our previous videos about the anchorage and bond. Next is about the lapping length. Lapping length shall be required when you need to transfer the stress from one bar to another. Normally, we would like the steel bars to be straight throughout a structural member. This ensures the best conditions of the members for the stress to freely distribute and taken by the reinforcement. However, there are some circumstances lapping will be required. Sometimes, when the required bar length exceeds the maximum bar length produced by the factory. For example, you have multi-span continuous beam requiring the reinforcement bar exceeding 12 meters. 12 meters is the longest bar length produced by the factory. Then you will need to connect the reinforcement in the concrete. In order to ensure the stress is effectively transferred from a bar to another, you will require the lap length. Let's say you have one reinforcement bar and you are lapping with another reinforcement bar. This will be the lapping length. So the calculated lapping length, it will be on basis of the equations here. Another situations you need lapping length, it will be when two bars of different sizes meet. This is often seen in continuous member, when one stretch of the beam require larger bar size, and then another stretch would require smaller bar size. But you know that the reinforcement bar needs to be continuous throughout the continuous beam. If you do not want to have the lapping length, you will need to use the larger bar size applied throughout the entire continuous member. This is rather wasteful, as it is not necessary. You can choose to reduce the amount of reinforcement bar provided. Since the extra is not necessary, that will lead to you two sizes of reinforcement bar meets. This is when you need the lapping length. The size changes and you will need a certain lapping length so that the stress can be transferred effectively from one bar to another. The formulas to calculate the lapping length is given here. This you can obtain from Eurocode as well. There are a lot of factors, alpha 1, 2, 3, 4, 5 and 6. These factors will have to be obtained also from Eurocode in accordance to the table and the formulas provided. If you wish to know more regarding the anchorage length and the lapping length, you may refer to our previous videos or refer directly the Eurocode.